Welcome to my series on conic sections. In this video, we are going to discuss about ellipse. We'll begin with understanding how do we form or get ellipse. And then we'll have a visual presentation of an ellipse. Change some of its parameter and see how, when the axis is changed, it looks like. When it is translated, how does it look like? And we are going to relate all these parameters. And then we'll take examples where from the equations we'll find the foci, the equation of directrix, the vertices, and all other parameters. And we'll do the reverse also. That is, if we are given the parameters, for example, if we are given the vertices and the focal point, how do we write the equation of an ellipse? Let's enjoy this journey. And here you will see a lot of presentations and graphs to make it simple for you to understand. Ellipse is a conic section which you get when the intersecting plane with the section is at an angle to the axis of the cone and it does not intersect the base of the cone. So ellipse is formed when a cone is cut by an oblique plane which does not intersect the base. Now the question is, what conic section will be formed if the intersecting plane is perpendicular to the axis of the cone, or if the intersecting plane also intersects the base of the cone? How do we get hyperbola in a conic section? So those are the other things which you could explore. Now let us see how an ellipse looks like. And we are going to soon model this ellipse with a mathematical equation. Here is a visual on ellipse. Let us try to understand its parameters. The graph seen here, which looks like an oval shape, is actually an ellipse. This one is wider along the x-axis and shorter along the y-axis. Well, these are the two axes of the ellipse. Wider one is called the major axis and the shorter one is called the minor axis. They intersect at the center. Here, the center is at the origin. The point where the ellipse cuts the major axis is called a vertex. There are two vertices in this particular case. I've labeled them as V and V dash. You can see the symmetry. It is symmetric about the y-axis as well as about the x-axis. The points marked here, F dash and F, are the focal points. Light rays, when reflected from the surface, will actually pass through the focal point. The length of the major axis is twice A. Well, what is A? When we write an equation of an ellipse in standard form, the equation is x square over a square plus y square over b square equals to 1. The denominator, which is a square, the term a, is actually the distance of the vertex from center. So that is a, and therefore the major axis becomes twice that value, 2a. The other vertex, which we really call co-vertex, is the intersection of the ellipse with the minor axis, labeled as m and m dash. The length of this is twice b.
So the other term, y square over b square. So that is this b. B is the distance from origin to the co-vertex. Correct? So that is how the vertex and axis are related.
In the presentation, you saw that the ellipse had major axis along the x direction and the minor axis along the y direction. In the present video, we have taken all the cases where the major axis is along the x direction. Now, when that is the case, the equation x square over a square plus y square over b square equals to 1 will have the value of a greater than b. If a is less than b, in that case, the ellipse will be elongated more along the vertical side. Now, here is an illustrative example for you. Find the coordinates of vertices and length of major and minor axes for the ellipse x square over 100 plus y square over 64 equals to 1. You can pause the video, answer this question. As we see from the equation, denominator of x square is greater than the denominator of y square. Therefore, we have an ellipse whose major axis is along the x direction. The vertex will be at a, and the value of a is square root of 100, which is 10. And therefore, the coordinates for the vertices will be plus minus 10, 0. The length of the major axis will be twice a, 2 times 10, that means 20. So that is how we can find the vertices and the length of major axis. Now let us find the coordinates of co-vertices and then we will find the minor axis length. The co-vertices will be the y-intercepts for the given ellipse, which is b. Square root of 64 is 8 and therefore plus minus 8 will be the y-intercept, and the coordinates for co-vertices will be 0 plus minus 8. The length of the minor axis will be twice b, which is twice 8, equals to 16. So I hope that is absolutely clear. Here is another question for you. I would like you to pause the video, answer the question, and then check with my solution.
Here is a practice exercise for you. We have given the graph of an ellipse. As you can see, the vertex V is at 3 and the co-vertex cuts the y-axis at 2, center being at the origin. I would like you to write the equation of this ellipse. Also find the length of major axis and the minor axis.
So here is the solution for our example 1. What you notice is that the ellipse has center at origin. Major axis is along the x-axis since it is wider, and minor axis is along the y-axis since it is shorter. The x-intercept are at plus minus 3. A therefore is 3 and the length of the major arc is twice a, which is 6. Vertices therefore along the major axis are 3, 0 and minus 3, 0. The y-intercept is at plus minus 2. The length of minor axis is 4. The co-vertices will be at 0, 2 and 0, minus 2. So therefore, we get our equation in the form of x square over a square plus y square over b square equals to 1 as
x square over 3 square plus y square over 2 square equals to 1, or x square over 9 plus y square over 4 is equal to 1. Correct? Now let us try to make a mathematical model for the ellipse so that we can have an equation to work with. Ellipse is a conic section, as you know. Ellipse is the locus of points in a plane that move in such a way that the ratio of the distance from a fixed point focus to its distance from a fixed line directrix is always constant and is less than 1. So if you take a point, for example P, then the ratio of distance PF to PM is always constant as mentioned here. It is equal to E. E is the eccentricity of an ellipse. The value of E is between 0 to 1. It is always less than 1. So this definition helps us to provide a mathematical model. And when we solve this equation, equating the ratio of these distances to E, we get an equation which is x square over a square plus y square over b square equals to 1. If you consider the vertex, then from vertex, the focal point is one distance which we are looking into, and from vertex to directrix, directrix is this vertical line shown here, is constant and it is E, right? You know what V is? V is a distance A away from the origin. So if you divide the line in the ratio of e's to 1, then you can get the equation which is x square over a square plus y square over b square equals to 1. Perfect. So that becomes a standard equation for any ellipse which has a center at the origin. Ellipse also has a unique property that any point on the curve, if you take, then sum of the distances of that point from the two foci is always constant. So f dash s plus sf dash will be constant. If I have another point t, then that distance t to f1 and f2, if you add this up, will be same as from s. So that also helps us to get more parameters about the ellipse. To find the mathematical model of the ellipse, we look into the property that ellipse is the locus of points in a plane that moves in such a way that the ratio of the distance from the fixed point focus to its distance from a fixed line directrix is always constant and less than 1. The constant ratio is called eccentricity of the ellipse, and it is denoted by the letter E, where E is less than 1. Working on this definition, we get that the focal point, which will always be on the major axis, the coordinates of focal point will be plus minus AE 0, and the equation of directrix will be plus minus A over E. An important parameter which we can always calculate is square root of a square minus b square, which we write as c. So c is the distance of the focal point from the origin when the ellipse is given in the standard form. So in that case, in terms of c, we can write the focal point as c comma 0 plus minus, there are two foci, and the equation of directrix can be written as a square over c. These equations help us to find the value or the coordinates of focal points and the equation of the directrix.
Now, here is a presentation on what really ellipses look like when you graph them. Also understand which parameter affects horizontal translation and what affects the vertical translation, how do the major axis changes or the minor axis changes. Answer the questions at the end of the visual.
Now we will visualize the translation of an ellipse. Do you know which parameter changes when the ellipse translates horizontally, left or right, as it is doing now? It is h. So if the value of h increases, it moves right. And if h is negative, then it is moving left. That is the horizontal translation. The equation changes to x minus h whole square divided by a square plus y over b square equals to 1. Correct? Now we will explore what happens when the ellipse moves vertically. The value of k changes, right? So if k becomes positive, it goes up, and if k is negative, it comes down. The equation changes. Can you tell me how does the standard equation of ellipse changes when the graph translates up and down? X square over a square remains same plus y minus k whole square divided by b square equals to 1. So the changes in the y value, as you can see, all the points vertically are shifted or translated. So that makes the equation as y minus k whole square. Well, at times, both the parameters can change, as you can see in this particular case. It is important to note that the directrix, focus, vertices are horizontal along the major axis. The value changes with the change in h, and the vertical value changes with the change in k, the vertical translation. Can you write down the equation of this translated ellipse? We can by finding the position of the center. Center actually gives us the translation. Originally, the center was at the origin. Now it has moved to a position which is hk, and that is how we get the value of h and k. So I hope that makes sense. An ellipse, when translated to the center at hk, can be defined with the vertices at h plus minus a, 0, co-vertices at 0, k plus minus b. The major axis will be y equals to h, and the minor axis will be x equals to k.
Now let us take some examples where equations of ellipse will be given to you and you can find what the vertices, focal point, and the equation of directrix is.
Here is example 2 for you. This time we have an ellipse which has been translated 1 unit up and 2 units left. I would like you to write down the equation of this ellipse. Find the length of the major axis and the minor axis. Find the coordinate points of the two vertices. Here is the solution for our example 2. It is a transformed ellipse where the value of a is 3, b is 2, h 2, k is minus 1. The ellipse has been translated 2 units right and 1 unit down. So the center is at 2 minus 1. The vertices will be at 5 minus 1 and minus 1 minus 1. You get this value by adding to AH plus and minus A values. The co-vertices will be at 2, 1 and 2 minus 3. Major axis equation will be y equals to 2, minor axis will be x equals to minus 1, and the equation of the translated ellipse is x minus 2 whole square divided by 9 plus y plus 1 whole square divided by 4 equals to 1. Here is question number 3 for you. We have shown an ellipse with center at origin. You need to find the coordinates for the vertices, co-vertices, length of major axis and the minor axis. Along with that, now you also need to find the coordinates for the two foci. The focal points are shown with f and f dash. So this is one of them, the other one is right there. And in addition, find the equation of the directrix as shown here. Pause the video, solve the question and then look into my suggestions. Now let us understand how do we find the coordinates for the foci and the equation for the directrix. In the example which you saw, the center remains at the origin. So the standard equation x square over a square plus y square over b square equals to 1 stands. The x-intercepts are at 4, the y-intercept at 2, and therefore the value of a is 4, b is 2. So we get the equation x square over 4 square plus y square over 2 square equals to 1. The x-intercepts also corresponds to the vertex, so the vertex are plus minus 4, 0, and the co-vertex will be 0 plus minus 2. To find the focus, C, which is difference of squares of a and b, square root, is a very important parameter. So we have first calculated C. C is the distance of the focus point from the origin when the ellipse is in standard position. C equals to square root of a square minus b square, substituting the values 16 and 4. 16 minus 4, we get square root 12, which is 2 square root 3. So the foci will be at plus minus 2 square root 3, 0. Now let us find the eccentricity E. E is equal to 1 over a square root of a square minus b square. Substituting the values, 2 root 3 for a square minus b square square root divided by 4. For a, we get square root 3 over 2. Equation of directrix is plus minus a over e. And so we get 4 over square root 3 over 2, which is 8 square root 3 for the equation of directrix. So the two directrix equation will be plus minus 8 over square root 3. The standard equation of this ellipse will be x square over a square plus y square over b square equals to 1. What are the values of a and b? Well, a is the point where the curve crosses the major axis, as you can see here, and the value is 4. So a is 4 for you, and b is 2, where the curve crosses the minor axis. So I have given you these two values, a is 4, b is 2, and therefore you do get the equation of the ellipse as x square over 4 square, which is 16, plus y square over 2 square, which is 4, equals to 1. Now with this, you get the coordinates for the vertices, which are on the x-axis, and therefore 4, 0 and minus 4, 0 are the two coordinates for the vertices, co-vertices, will be at 0, 2, 0, minus 2. Now the question is, what is this length? Length of major axis is twice A. A is 4, it is 8 units, and the length of minor axis is twice 2, which is 4 units. Let's calculate focus points. The distance between the origin and the focus can be found using a formula which says C is difference of a square minus b square square root, correct? So 16 minus 4 square root, 16 minus 4 is 12. Square root of 12 gives you the value for f, and minus square root of 12, 0, will be the coordinate for f dash, the other focus point. Well, square root of 4, square root of 12 can be written as, it is 4 times 3, so it could be written as 2 square root 3. So plus minus 2 square root 3, 0, will be the coordinate for f. Now, how do you find the equation of the directrix? You know the value of C. From there, you can find the equation of the directrix.
Now let us summarize. How do we find the focal points and the equation of directrix? When the ellipse is translated and the center goes from origin to the coordinate point HK. All the formula is shown there in the screen. I'm just going to read them out for you. X minus h whole square divided by a square plus y minus k whole square divided by b square equals to 1 will be the equation for the ellipse. X intercepts will be at x equals to h plus minus a. Vertices will be at h plus minus a, comma k. Y-intercept will be at y equals to k plus minus b. Co-vertices therefore will be at h, comma k plus minus b. The major axis will be y equals to k. The length remains at 2a. Minor axis will be x equals to h. Length will be 2b. To find the focal point, it is better to find the value of c as shown here as square root of a square minus b square. Focal distance from the origin to the focus will be now at h plus minus c and the y value being k. Eccentricity E, the formula is given here. It could be calculated with c divided by a, where c is a square minus b square square root as shown. For an ellipse, the value of E is between 0 and 1. Equation for the directrix will be x equals to h plus minus a over e, and it can also be figured out as h plus minus a square divided by c. I hope you find these formulas useful in calculating the values.
Here is the fourth example. From the given graph, you have to find the equation of an ellipse. After finding the equation, find the coordinate points for the vertices, co-vertices, and the two foci, and then find the equation of the two directrix. You can pause the video, answer, and then look into my suggestions. First thing we notice is that the graph of an ellipse shown here has been translated. Note the translation and then write down the equation of the ellipse. The graph is translated 2 units right and 1 unit down. That means h value is 2 and k value is minus 1. Therefore, the equation should be x minus h over a square plus y minus k over b square, where the value of h and k are 2 and minus 1 respectively. How do you find the value of a and b? Well, look at the major axis. There you go. So the major axis intersects V at 5, the center being at 2, so the distance between the two is 5 minus 2, which is 3. The value of A is 3 as written here. And the value of B is, from the center, you can go up 2 units to reach the ellipse. So that is the value of B along the minor axis. So now you have A and B value also, and therefore you can include them. A square being 9, B square being 4, which comes in the denominator. Perfect. You got the equation. How will you find the focal point? The focal point value is C, which you can find by difference of squares of A and B and square root them. So 9 square minus 4 square square root gives you the value of C, and to this what? That is, the C is the distance between 0 to F, right? And it has now moved 2 units to the right from the center. So add 2 to this, the y value being minus 1, since it has moved down by 1 unit. So I hope that is clear to you, correct? The other focal point will be what? Again, C, and has moved 2 units to the right, correct? So C minus 2, that is the x coordinate value, and the y being minus 1, correct? So you got the value for the coordinate points of F. Now, can you find the equation of the directrix? I hope you got the answer for example 4. Here is the summary of the solution. As you saw, the ellipse was translated 2 units to the right and 1 unit down. That resulted into the center being at 2 minus 1. From the center of this ellipse, along the major axis, which is horizontal, the value of A is 2, and the minor axis, if you go, the vertex is at 2. So A is 3, B is 2. From 3 and 2, we can find the value of C as 3 square minus 2 square square root, which is square root 5. To find the focus, it is C and the K value, which is 2 plus square root 5 minus 1. 4.24 minus 1 is one of the focal points. The other one, to the value of H, you have to now subtract the C value. That is going to give you the x coordinate, and y being at minus 1. So it will be 2 minus square root 5 minus 1, calculated to 2 decimal places will be minus 0.24 minus 1. Eccentricity can be calculated as 1 over a times square root of a square minus b square. Since square root of a square minus b square is c, we can divide square root 5 by 3 to get the value of eccentricity as 0.745. Equation of directrix is 2 plus minus a over e, which is 2 plus 3 divided by 0.745, and that gives you the equation as x equals to 6.03. The other one on the left will be 2 minus 3 over 0.745 equal to minus 2.02 as calculated. I hope with this you have learned all about the ellipse and the transformed form of the ellipse. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'll be great. Thanks for your time and all the best.